Okay, so this video is about how to find the values of the trig functions at quadrantal angles. So what we're talking about is when we're given points that fall on the x or y axis, or if we're given angles of rotation that place us on the x or y axis, how we then would find the values of the 6 trig functions. So what we need to remember here is our basic trig function definitions, again, that we've been working on throughout this entire section. So we remember sine is y over r, opposite over hypotenuse, etc. Again, I just want to highlight the relationship between the function and its reciprocal. Remember, each function pair has one co-function, one non-co-function, so sine goes with co-secant, cosine goes with secant, etc. So in this particular example, we want to talk about, I want to give you the point 6, 0, and I want you to tell me the values of the 6 trig functions. So 6, 0 will place us somewhere around, let's say here. So here's 6, 0. And the idea is there is some circle of a radius that would pass through this point. So we'll say that guy goes something roughly, it's more of an ellipse than a circle, but you get the gist. So a circle that looks something like that. And I actually can't take that. I have to fix that. So let me see if I can do it slightly better than that. Because that will just bother me and probably bother you. All right, so let's try again. So let's go more around like that-ish. Okay, so this is a circle of some given radius. Now, the question is, what is the radius? What is the value of x for this point? And what is the y? Since the ordered pair is the point 6, 0, we know that ordered pairs are x, comma, y. So this question gives us directly that x is 6 and y is 0. The question is, what is r? And to figure that out, it just takes a little bit of thinking about our question. So in this particular instance, if I look at this diagram, usually we've been thinking about this guy here as being our radius, but the radius just goes from the origin to any point on the circle, so this segment right here would also be considered the radius. If that is my radius, we know that its length is the same length as from 0 to this point, so this right here has a length of 6. So in the diagram, when we're falling on the circle itself, the radius length is the same as either the x or the y value. X value if I'm on the x-axis, y value if I'm on the y-axis. So in this case, we know that the r value is 6. So if I want to go through and write the values of sine, cosine, and tangent, the sine value here would turn out to be y, which is 0 over 6, which is just 0. The cosine value is adjacent, or x value, which is 6 over 6, which comes out to be 1. Y over x is 0 over 6 again, which simplifies to 0. And then on the other side, for all of our reciprocal functions, a reciprocal of sine here is cosecant, and that's 6 over 0. But when I do 6 over 0, I get undefined. I can have a value of undefined. That is a possibility. So remember, whenever you divide by 0, your value of your fraction is undefined. Continuing, secant is r over x, so that is still 6 over 6, which is 1. And then the cotangent value here is x over y, which is 6 over 0. So again, that's undefined. And for your work, you need to say that it's 6 over 0 and your final answer is undefined. So that would be how I evaluate for a point in space. So similarly, if I want to take that and I want to move it, so now it's at 0, 3, so what I'm thinking about is my coordinate axes. The point up here is 0, 3. And again, there is some circle with a given radius, or with a set radius, that point falls on. So in this picture, again, this is 0, 3, 0, 3. That's the same thing as x, y. So we know that x equals 0 and y equals 3. And again, the question is now, what is r? So the r connects us from the origin to the circle. So again, we've been drawing it like there, but it could also be here. All the radii of a circle are congruent. So this length here is 3, so my r value is 3. It wants the sixth trig function, so here we go. So let's see. Sine of theta is y over r. So y is 3, r is 3, so that simplifies to 1. While I'm here, I'm going to talk about its reciprocal. Cosecant theta would also be 3 over 3, so it also is 1. Cosine theta, cosine is x, which is 0, over r, which is 3. That reduces to 0. And its reciprocal secant would start out as 3 over 0. Dividing by 0 is bad. I can't take something and make it into no pieces. So this guy is undefined. Our last two, tangent of theta is y over x. So that's 3 over 0. That is undefined. Its reciprocal is cotangent. Cotangent is x over y, that's 0 over 3, so the cotangent value here is 0. So those are the values of my 6 trig functions, given the point 0, 3, a point on the y-axis. The last thing that we can do is be asked to evaluate quadrantal angles based off of a given angle. So first steps for each of these guys would be just to figure out where the angle puts us. So I'm at 270, that starts at 0, has a positive rotation around to here. I don't know the radius of the circle. This isn't like the previous two examples in that way, but I know that this point is 0, comma, some negative y value. And I would know that this is 0, negative y, then the radius of my circle, this r, would just be y. Radius is always positive. So here we know that x is 0 and y is negative y and r is positive y. And again, the y value is negative y because it's going down. So it wants the sine of 270. Sine is the ratio of y over r. So in this picture, that would turn out to be negative y over r, which is y, and that reduces to negative 1. So that's our first question. Our second question, cosine negative 180. So negative 180 starts here and goes around to here. I don't know what the point is in space, but I do know it is to the left x unit. It's in up 0 units. So if I'm thinking about it, x is negative x, y is 0, and then the radius is going left, but it doesn't make a difference. The radius is just the quantity of how far left we went, so the radius here is x, always positive. So when I come up to my function, I remember that cosine is x over r. And if cosine is x over r in this example, that means that it is negative x over r, which we said equals x. So once again, I get a value of negative 1. Coincidence they're both negative 1? Maybe. Maybe not. We'll have to wait and see. Certainly not a coincidence they're both coming out with these 1s, and that will come up with as we start to move on to our next section. Next example, tangent 9D. 9D is here. Tangent. So this is some point, x is 0, y is positive y, some positive number. The radius here is this length right here. That's up y units. That looks awful. Up y units. So now we have that x is 0, y is y, that's ridiculous to write, and r is also y. So if I'm evaluating the tangent of 90, tangent is the ratio of y to x, so that would just be y over 0. So the tangent of 90 would be undefined. And then our last example, secant negative 90. So starting at the positive x, rotating down. So that's where negative 90 falls. So my point is maybe somewhere along here. This has an x value of 0 and a y value of down y. The radius, this is x, y. Our radius is down y, so it's just y. Secant is the reciprocal of cosine. So cosine is x over r, so this is going to be r over x. So the radius here is y. The x value here is 0. So I could say that the secant of negative 90 is y over 0, which is always undefined. If the numerator is 0, then the answer would have been 0, which also happens. And if the denominator is 0, then our overall value is undefined. And that is evaluating quadrantal angles.